Alright, so without a further delay, let's now start. So, sir, pwede pong tanong. Okay, ano yun, Mr. Isaac? What is your question? So, before we start, para masagutan natin ang inyong mga katanungan. Wala naman. Do you have a question, Mr. Isaac? You can just use your mic para mas mabilis tayo, no? Hindi yung para... Right, so while waiting for the question of Mr. Isaac, so let's start now our topic. Oops, check na ulit. Pwede po ba diretso sa calculator kapag ano yung... Yeah, sure. You can do that one, but it's not advisable. Bakit? Kasi okay yan for checking, pero sa mathematics kasi kailangan mo i-show or kailangan mo i-prove. Hindi pwedeng, let's say, give an equation and then one missing variables and then shift solve and then sagot ka agad, magic yon. Okay? So applicable yon kapag hindi humihingi ng solution yung instructor. Like this one, sa online distance learning tayo, sa nasa inyo na talaga yun kung naiintindihan nyo ba talaga or hindi. Okay, so you can use shift solve but not advisable.
Sir,
Pwede naman.
sir, pwede yung ano, yung...
May iba pang question?
Sir, pwede
Isaac?
malaman yung formula, sir?
Formula ng ano?
Yung find the missing, sir, na ano?
Walang formula doon. All you need to do is use your calculator. Okay? So, mag-equate ka lang. Actually, maraming tutorial sa YouTube. Okay? Madali lang sanang ituro kung mapapakita ko sa'yo. So, bale, kung may missing na isang variable, gamit ka lang ng kahit anong variable dito. So, marami tayo dito. A, B, C, D, E, F, X, Y. Yun, so napakarami. So, isa lang naman ang kailangan mo. And then, i-shift solve mo lang yun. And then, hahanapin niya na yung value mismo ng variable niya. Okay, as long as isa lang yung variable na walang value. Yung iba, given na. Okay, you cannot solve two missing variables in one equation. So, in that case, you need two equations to solve two missing variables. Unknown po yung R. Depende. Okay, so sa quizzes naman na binigay ko, yung iba unknown yung R, yung iba naman given yung R. So pag hindi naka-indicate doon, ibig sabihin unknown yung R. So yun yung hinahanap. Okay, R is the growth rate. Okay. Anything else? You can search on YouTube if you want how to do shift solving or how to solve one using a variable using shift solve in your calculator. So it is also important that you indicate the version of your calculator like FX991EX or 991ES para same na same talaga yung gagawin niya. Okay. How about the others? Do you guys have a question or clarification? Alright, so I think wala nang questions si Mr. Garcia or Mr. Isaac. Okay, so let's start now. So, pwede na ba? Or may mga katanungan pa kayo para mapanatag ako? Naghihintay ako ng mga katanungan niyo eh.
Wala na po, sir. Thank you po.
Alright, so gumagana naman pala yung mic mo eh. You should have used it in the first place para mas mabilis tayo. Okay, I recommend you guys to use your mic. Don't be shy. Okay, wala namang mawawala eh. Mas maganda ngayon na enhance yung communication skills natin. Alright, so let's start. For the chapter 2 is the language of sets. Okay, but before this, you have to know what is set. Okay, so set is a formal mathematical term was introduced in 1879 by George Cantor. Okay? So in other words, or yung pinaka-short definition natin ng set, it is a collection of elements. So if there's two elements or one element on that, let's say, ano bang tawag dito, in that box or in that slot, we call that one set already. Okay? Like for example, we have here set C is the set of all countries in Asia. Then Philippines is an element of C or set C. So we have here a set name called C. Okay? So kahit ano naman yan eh. Pangalan lang naman tong set na to. Okay? Kahit anong pangalan siya. So in here we have set, namely C. Okay? Wherein the definition of this one is, it is a set of all countries in Asia. So Japan, Philippines, China, Vietnam, and so on and so forth. So marami. So one example is, Philippines is an element of C. You can also say Japan is an element of C. What else? Vietnam is an element of C. Korea is an element of C. So napakarami. Anything that is under Asia, okay, that is an element under C. Okay. Next one is I is a set of all integers ranging from 1 to 100. Then the number 26 is an element of I. Okay, so I hope this one is clear. As you can see in set, we have a certain condition, or we have a certain range, or we have a certain, ang pinakatamang term, we have a certain sakop, we have a certain, kalimutan ko yung pinaka-proper term. Pero when we say set, it has a boundary, okay? It has a limitation, wherein this is the minimum requirements and then up to this point only. Like for example, I contains 1 to 100. So it has 100 elements to be exact. 101 and above, or -1 and below, or 0 and below, is not an element of letter I anymore. Okay? So 26 is an element of I, 50 is an element of I, 1 is an element of I, or anything that is within the 1 to 100. Right? Okay, so moving on, we have here the notation. So this one is quite simple. All you need to remember is this symbol. Okay, so this symbol means element. So we read this one. If S is a set, okay, let's say this is a set, the notation X symbol element and then S means that X is an element of S. So we read this one, X is an element of set S or S. Okay, so the opposite of this one is, actually it should be the same like this. Okay, the same symbol like this, but with a bar or with a line on the top. Okay, or with a comma on the top. Okay, just to identify that this one is different from this one. Meaning, if it has a bar line on the top or a comma on the top, it means that it is not an element. Okay, this one is an element. This one is not an element. So the notation X, E, and then S means that X is not an element of S. So just take note those two symbols. So this one, oops, this one is an element, and then this one is not an element. Okay, so I hope you got the idea of this one. Okay, so moving on, let's have a very basic example. So we have set A, set B, and then set C. So for set A, we have 1, 2, 3. For set B, we have 3, 1, 2, and then C is 1, 1, 2, 3, 3, 3. So the question is, what are their common elements? Anyone?
1, 2, 3.
So their common elements are 1, 2, and 3. So just look for this element onto the other set. So 1, we have that one here. We have that one here also. So 1 is one of the common elements. How about 2? So 2 is also on the set B, and then 2 is also on set C. So we could say that set element 2 is also common elements of A, B, and C. How about the 3? So 3 is also here, and then also here. So we could say that their common elements are 1, 2, and 3. Okay. Okay, so moving on. here's the solution. Okay, so we have already answered this one. Moving on, we have another example. So we have here a set wherein it contains an element of 0 and then a 0. So it is asking us, are they equal? Okay, so actually there's already an answer. Supposedly this one is not here. If it's in PowerPoint, this will not show. So due to not having a transition in PDF, so this is already right here. Okay, so according from here, this set and then contains an element of 0 is not equal to 0 because this one is a set with one element, name 0, wherein the other one is just the symbol that represents the number 0. Okay, so if you're going to compare those two via drawing, okay, so if you heard the word set, just imagine that it is a box. Okay, equal to, and then the other one is a number 0, wherein this set contains an element, namely 0. So just by looking at this one, of course, this one is not equal to this one. Okay, so this is a set wherein it has an element of 0, and then the other one is just a number representing the number 0. So they are not equal. Okay. So I hope this one is clear. This one is a set, the other one is not a set. Okay, another example, how many elements are there in the set? 1 and then that one. Okay, so I'll leave the reading to you guys. So how many elements in this set? Hello guys, you guys still there? How many elements do we have in this one, in this set?
Hmm.
1.
2.
One only? Okay, so yung sumagot,
2, sir.
yung may mga sagot ng 1 dyan ha, hindi kayo nagbabasa ha. Dito na yung sagot eh. Okay, so in here we have a total of 2 elements. Okay, so the explanation for that one here is the set, this one, an element of 1, and then another set with an element of 1 has 2 elements. Okay, 1 and a set whose only element is 1. Okay, so if you're going to take a look on this one, if you're going to read that one, wait, let me just delete this one. So this curly bracket is already a set, so you can say it's a box already, and then it contains an element 1, and then the other one is a set, another set, okay, wherein that set contains an element 1. Okay, so in here, what we're only going to think about is what is the count of the elements that is inside of the outer box or the most outer box. Okay, we will not measure how many elements is inside of the inner box or inner box. Okay, what matters is the outer box only. So in here, this one is counted as one element, and then this box is counted as another element. Okay, so even though let's say this one has another element, let's say 2 and then 3, the count of elements of this set is still 2. Okay, so we don't care whatever is the one or how many counts of element is inside of this set. Okay, what matters is the outer set only, okay, which is this one. So the count of elements on this one is 2 elements. Okay, so I hope this one is clear. Moving on. So how many elements are there in, oops, this, not this one. Okay. Another example, for each non-negative integer n, let u sub n, positive n, and then negative n. So find u sub 1, u sub 2, and then u sub 0. So in here, we're going to find the value of this set if we have 1. And then another one is we're going to find the values of this set if we have the value of 2. And then lastly, we're going to find the value of this one if we have 0. So basically, so in here, we're just going to substitute this n through this element. So we have here your n for the first n is 1. So for u sub 1, it is equal to, so the first one is positive. So just put here positive 1. And then the next one is negative n. So just substitute that 1. But of course, you have to copy the sign. So in here, we have 1 and then negative 1. Okay, but how about the u sub 2? So what are the elements of u sub 2?
-2.
What is that, Mr. Ronald?
2 -2, sir.
2 and then negative 2. That's correct. How about u sub 3?
3 -3.
Oops, sorry. Yeah, okay. So let's just answer this one. U sub 3 is 3 and then negative 3. Okay, but how about u sub 0? So supposedly it's u sub 0, not u sub 3. Okay, how about this one? U sub 0.
0 lang, sir.
0 only. Why?
Wala pang negative na 0.
There's no negative 0 wherein if you say negative 0, which is the same also with 0. And one more thing, let's say we have negative 0. And then if you're going to simplify this one is the same with 0, 0. So as you can see right here, we have repeated elements inside of a set. In a set, if there's a repeated element, you can remove the other and then just remain one. Okay, so in here, say we have 0, 0, and then 1, 1, and then 3, and then 2. So in here, you could say that this one is equal to 0, 1, 3, and then 2. Okay, so you can remove the other 0, and then you can remove the other 1. So those two are just the same. Okay, so no matter how many times this element occurs, if it's already in that one or inside a set, so you can remove the other. Okay, so this one is the same with 0, 1, 3, 2. Okay, so moving on, let's have an exercise. So we have set X contains elements ABC, set Y contains ACB, set Z contains ABB, CCC. So the question is, what are the elements of X, Y, and Z? And then how are X, Y, and Z related? So what are the common elements of letter A or X, Y, and Z?
ABC.
Common elements of X, Y, and Z is equal to, what are your common elements? This one is just similar with our first example.
ABC, sir.
ABC.
A, B, A, B, and C. So all you need to do is check whether this element is on the other set, the same with B and then C. So as you can see, A is on the X, Y, and Z. B is on the X, Y, and Z also. And then lastly, C is also in the X, Y, and Z. So their common elements are A, B, and C. So how are they related with each other? So we could say that all of them have the same common elements. Okay. How about letter B? How many elements are in the set?
3.
3, sir.
So in here we have a total of 3 elements. So again, what we're only counting is the outer set. So we don't care how many elements is inside of the set, inside of that set. Okay, so it's quite weird to hear, but there's a set inside a set, something like that. Okay. So what we're only worried about is the outer set, okay, not the counts of elements of the inner set. Lastly, for each positive integer x, let e sub x is equal to x and then x squared. So find a sub 1, a sub 2, and then a sub 3. So what are the elements of a sub 1? So again, all you need to do is substitute this value to our x.
1, 1.
1 and then 1. And then you can
Okay.
simplify this one further.
Only
One.
For
1, sir.
in, you could say that 1 only. Okay, since in set there should be not repeated elements. This one is considered as 1 element only. How about a sub 2? What are the elements of a sub 2?
2 and 4.
2 and 4. Okay, very good. How about a sub 3?
3
3
and
and
9,
9.
Yan na. Okay, see, very easy. Okay, so moving on, we have here the special symbolic names. So take note, if we have a set R, set Z, and then set Q, so meaning this set R is the set of all real numbers. And then for Z, it is a set of all integers, and then for U, it is a set of all rational numbers or quotients of integers. So in sets, you can use any other alphabet or any other vowels aside from R, Z, and Q. Okay? Because they have their own definition. In R is a set of all real numbers, and then Z is for integers, and then Q is for rational numbers or quotients of integers. Okay, so just memorize those 3 symbols so that you won't get confused once you're trying to answer an example. Okay, but before that, you have to know what are the numbers under real number. Okay, so of course we have here the natural numbers, whole numbers, integers, then rational numbers, and then real numbers. So everything that is inside of this box are real numbers. So the only one that is not a real number is an imaginary number. Other than that, pi is square root of 2, that is already a real number. Okay, so just take note that if you say natural numbers, 0 is not included. And then if you say whole numbers, 0 now is included. So 1 to infinity. And then for integers, so this one now is including everything as long as it's a whole number. Okay, so negative to infinity and then positive to infinity, including the 0. And then for rational numbers, the same with integers, but in rational numbers, it is with decimal. Okay, so infinity negative and then infinity positive, including the 0. Okay, so and then pi is also a real number. Okay, so we have here a set builder notation. So let S denote a set and let P of X be a property that elements of S may or may not satisfy. So we may define a new set to be the set of all elements X in S such that P of X is true. So we denote this set as follows. Okay, so another notation wherein we call this one set builder notation. So this is the most complete notation when it comes to set. So we have here the element x. So x is an element of set S. And then this one, you read this vertical line as such that. Okay. So x is an element of set S such that p of x. So this p of x is the rule or the condition, okay, or the range or the boundaries of your set S. So for you to appreciate this set builder notation, so we're going to use this one on the following examples. Okay, so using the set builder notation, given that R denotes the set of all real numbers, so this is just a recap actually, and then C is a set of all integers, and then Z plus is a set of all positive integers. Describe each of the following sets. So we have an additional condition here, or additional special naming when it comes to set. So Z is a set of all integers, negative or positive. But in here, we have Z plus, wherein it is a set of all positive integers. So take note, if it has a sign plus on above Z, meaning you're only getting the positive integers. Okay? So vice versa, if this one is negative, then it is a set of all negative integers. Okay, so for letter A, we have here x is an element of R such that it is ranging from -2 or less or greater than -2 and then less than 5, where element x is a whole number. Okay, so from that set builder notation, what are the elements of letter A?
Zero, 1, 2, 3, 4.
0, 1, 2, 3, 4. Sure?
Yes, sir.
How about -1? Isn't it that negative numbers are also real number?
But it's not a whole number, sir.
Let me see. Whole numbers. Yeah. I think there's a conflict on this one. So I should have removed this one. So in here we have two overlapping rules, wherein if it's a real number, then anything that is below this one. But in here, it overlaps by another rule, wherein element x is a whole number. Why I didn't notice this one? I've actually already discussed this one last year, and then no one complains. We've included -1, even me. Okay, so that's a good thing that you you saw that whole number is only 0 and then to the positive, so no negative numbers. Okay, so I think I have to do some correction on this one. So for the correct answer on this one is 0, 1, 2, 3, 4. So thank you very much for that one, Mr. Ronald. And then the other girl who corrected me. So for this one, it's 0, 1, 2, 3, and then 4. Okay, how about letter B? So we have here the set of all integers. What are the elements of letter B? Anyone?
-1, 0, 1, 2, 3, 4.
0, 1, 2, 3, 4. That's correct. How about the last one, letter C?
Zero, 1, 2, 3, 4.
Z plus. Okay. So here, 0, 1, 2, 3, and then. Right. So there you go. We have here 0, 1, 2, 3, 4, and then -1 to 4, and then 0, 1, 2, 3, 4. All right. So any questions so far? So this is how you use set builder notation. Any queries or clarification? None? All right, so it seems that none of you has a question. Okay, so moving on. Let's check your progress. So given that R denotes the set of all real numbers, and then C is a set of integers, and then Z minus is a set of all negative integers, describe each of the following sets. Okay, so we're still going to use this one. So what is the answer in letter A? Anyone? Any volunteers? So X is an element of real numbers, where it is ranging from -5 or greater than.
Zeros. Zero lang ata. Ba? Or
0 only. So
Negative
in
4,
here,
negative 3,
the answer
real
is
number.
-4, -3, -2,
negative 1.
-1, and then 0. So again, if it's real number, it covers everything. So negative, positive, or even if it has a decimal, so still, this one is under real numbers, so negative or positive. All right. How about letter B? X is an element of all integers.
-4, -3, -2, -1, 0.
4, -3, -2, -1, and then 0. So this one is just the same. Oops. 4, -3, -2, -1, and then 0. So it's just the same with letter A. How about the last one?
-4, -3, -2, -1.
Okay. So see, it's very easy. So this one's like for grade 5. Okay. So now you know on how to use the set builder notation. So I will give you ups later. Okay. So the quiz will be later on. All right. So for now, we will stop right here. We will discuss the subsets later on since we only have less than a minute. So again, wait 5 to 7 minutes since I need to convert the pre-recorded video into MP4. All right, so you may now leave if you don't have a question anymore, and then just see you on the part 2.
Bye, sir.
Goodbye.